So we have this capacitor whose inter-electrode space is filled up with poorly conducting medium with active resistance R. So basically we can connect the resistor in parallel with the capacitor. Now to this arrangement, to this capacitor, we are given a external voltage supply, that is Vm cos omega t. We need to find what is the current as a function of time. So this is a parallel circuit. So in series circuit, if you remember, we were taking the current as reference because current was same across all components in series circuit. Here we have a parallel circuit. So here the voltage across all the components is same. So it's always convenient to take voltage as our reference. So then the resistance of course is aligned with the voltage. I mean the current through the resistor. Now we know the current in capacitor is ahead of voltage by 90 and current in inductor lags behind the voltage by 90. So he has not given an inductor, but this is the general case. And IC is Vm by Xc, IR is Vm by R, and IL is Vm by XL. So all these represents the maximum value IC, IR, and IL. And then we have phase. So to check the phase, let's draw what is given to us. So we have R and C. So we will have IR and IC. So let's draw that. So IR will be here, IC will be here. And this is the angle phi at which final current will be there. And you can see current is ahead of voltage because this is a capacitor dominated circuit. So there is no inductor. The value of phi will be tan inverse IC by IR. And IC is Vm by Xc and IR is Vm by R. So this becomes R by Xc. Xc will be 1 by omega c. So this is tan inverse omega CR. So current leads the voltage by tan inverse omega CR. So now we can write the current. So that will be again IR and IC are perpendicular to each other. So the value of this current will be root of IR square plus IC square cos of omega t plus phi. So omega t is the phase of voltage. Current is phi ahead. So cos of omega t plus phi. You put the values of IR and IC here in terms of Vm and R and Vm and Xc, you'll get this. All right.